keynote speaker this morning is Kristen Ratan. She's the founder of Stratos and the nonprofit Incentivizing Collaborative Open Research. Kristen became an advocate of open access in the early 2000s, culminating as publisher of PLOS. By 2015, she had broadened her interest to include open source and co-founded the Collaborative Knowledge Foundation. In 2019, she started Strategies for Open Science, which works with institutions like ours and funders to conceive and implement open scholarship solutions. I will say that working with Kristen, I've learned that she's also just a really gifted collaborator and connector of people and ideas around this really important topic. So join me in welcoming Kristen.
Thank you, Elizabeth. Thank you so much. Can everybody hear me? Yes. Great. Awesome. Greetings from the land of COVID. I hope that my voice will in fact hold up. I will do my best. So it's great to be here today. This is topics near and dear to my heart, the intersection between open scholarship and open source. And there are many different intersection points that I want to talk about today. Excuse me, here we go. So I don't think I need to introduce the concept of open science or open scholarship to this group, but to suffice to say that it covers a broad range of potential activities, all of which increase the transparency, immediate access of research throughout the research lifecycle. Many people define it in different ways, and there's good reasons to do that. And we'll be talking a little bit about some of these and how they intersect with the fact that it is the year of open science. Just as a note, I will be using the term open science and open scholarship because I'm used to saying open science, but open scholarship really is the preferred term because it's a much more inclusive term. And so I'll do my best to remember that. So why do all of this? Again, I don't think I need to advocate to this group. But the original thinking around open access publishing was that it would increase the equitable access to research globally. Research that maybe only a few have the ability to conduct would then be available to everyone. But also there are hopes that we have for why open scholarship can improve our lives. And that has to do with accelerating discovery. Sharing things early, sharing the complete story in theory should hopefully help others build on that more quickly and improve outcomes, increasing the reproducibility of work, and then perhaps even more importantly over time, reuse of other people's research. So everyone isn't reinventing each experimental data collection, reinventing each piece of code over and over again. Many of us hope that open will fuel more collaboration across research, and there is early evidence that from the science of team science, the collaboration can increase and accelerate research outcomes as well and improve them. It may multiply the impact, reduce the cost, and of course ensures the persistence and legacy. As the former publisher at PLOS, we did a study looking at, this was done back in 2014, and we looked at authors who had published in PLOS Biology and asked them, those who had published 5 years ago, do you still know where your data sets are from these publications? And 70% did not. So that's the sort of thing that open scholarship in theory can help with, which is ensuring persistence and the legacy of this information over time. So for those of you who've been in around this like I have, all of this concept around open access really followed from open source. That was the inspiration. Early open access advocates back in the late 90s used to call for the freedom of information. And then the Budapest Open Access Initiative really launched what was over time a very successful open access initiative. Many things have happened along the way, but I'm going to focus on what's happened most recently with the policy landscape changes that we're experiencing both in the US and abroad. So most of you who are part of the University of California know that back in 2013, there was an open access policy that was adopted. And this has certainly increased the amount of open access sharing among faculty and student authored works across the campuses. And it pioneered the idea that you have to tie things like licenses and copyright to open access. But then with the pandemic, there was really a forcing function towards a move from just open access towards open science. All of a sudden, with the pandemic, researchers were sharing their data real time around the globe. They were pre-printing very rapidly, and funders started to shift their focus almost exclusively in many cases to COVID. What was also interesting was publishers opened up access, those who still have paywalls, which is many, opened up access to any COVID-related research to anyone in the world. And while this they did as in the hopes of appearing very generous, it also had the backfire effect that people said, well, if you can do this for COVID, why can't you do this for all of the other information out there that you're still holding behind paywalls? But it really opened people's eyes as to the potential power for open, and I think accelerated some of the policy changes we've seen recently. So Europe, of course, ahead of the US in terms of its plans for open science, and then UNESCO put out recommendations on open science. And then more recently, in August 2020, in the US, a sort of bombshell dropped with the Nelson memo that came from the Office of Science and Technology Policy, mandating, or at least offering the guidelines that would then mandate public access to all taxpayer-funded research. So you'll notice it doesn't say open access, it says public access. And it invokes the taxpayer as the payer of that research and says that information needs to be made fully available without embargo in a machine-readable format with adequate metadata. But I think what the real sort of shock for many people was the includes underlying data portion. And we'll talk about what that means, because that really is a fundamental shift from just open access to all the other opens like data that we've been, many of us working towards. So in January, just 6 months later, the Biden administration went ahead and declared 2023 the year of open science, as Elizabeth mentioned. And that's led to a lot of different activities and interests, including the program that Elizabeth mentioned here at UCSC. So the partnership that Elizabeth mentioned between the Office of Research, the libraries, and ITS that I'm helping to facilitate is a pretty exciting one in that it's pioneering how a campus can not just get behind open scholarship, but really embrace it, and how the campus can not just look to comply with the policies that the US federal agencies are going to bring down, but also get behind the spirit of open scholarship, which says that we're not just doing this to check a box, we're really doing this to improve research and to benefit, humankind, so to speak. It's good not just for humanity and the planet, but there's a lot of emerging evidence that being open as a researcher actually broadens the reach of your work and facilitates career advancement. And of course, these mandates are going to require that not just articles published open access, but that the underlying data be shared. And this is exciting for those of us who have been proponents for a long time, but it also means that we need to get ahead of what does it mean to share data, where does it need to go, and how can we make it most impactful and most usable. The other new piece of information is that this is cross-disciplinary. In the past, memos that have come out of the White House Office of Science and Technology have focused mostly on STEM, and this does include social sciences and humanities. So you'll be hearing more, especially if you're on campus, but certainly across the other UC campuses about this initiative. We'll be learning a lot as we implement it, and we'll be sharing what we learn so that other campuses, hopefully it can provide a blueprint for other institutions looking to do similar things. So some of the things we'll be covering are understanding and clarifying these policies and what do they actually mean. NIH, for example, has a different policy from the other agencies. It was ahead of the game and rolled that out before. So it's really important that people have that understanding. We're conducting a baseline analysis of what the current status of open science and open scholarship is across UCSC. And we're conducting a survey that Elizabeth mentioned that if you're on campus, you'll see a link to. But the main thrust of what we're trying to do is implement a thriving ecosystem that will last well beyond this year of open science. So that means educating people about what it means to be an open researcher, an open scholar, what they need to do, how they need to do it. There are emerging best practices and even some standards that people will need to be aware of. We'll be putting together a set of preferred tools, repositories, and partnerships that will help people who are not familiar with open scholarship. And then, of course, we'll be measuring the impact. So we're going to be looking to move the needle year upon year. And so some of the ways that we measure the status quo now, we'll be able to re-implement and use to see how we do in subsequent years. So I mentioned this status quo assessment. We engaged with a service called DataSeer, which is an AI tool that actually machine reads published articles or unpublished manuscripts as well. But in this case, we took a small sample, preliminary sample of articles published with UCSC affiliations. And we looked to see how much data was generated and then shared. We'll be doing this with a larger sample next, but I wanted to be able to share this preliminary sample with you today. So it's roughly 300 articles, and roughly 60% of them have shared at least one data set in an online resource. So that doesn't mean they're compliant with these new policies. We don't yet know all of the online resources and whether or not they're actually fair repositories. And we also don't know if they've shared all of the data sets in a given article. But it's a starting point, and it's, while encouraging, it leaves us a long way to go to get to the closer to 100% that we would need. You'll notice that almost 20% are sharing data in supplemental materials within an article. This is obviously a less than ideal way. It is not compliant with policies, and it's not compliant with best practices, because typically those things aren't indexed by search engines. They're not really findable, and they're not necessarily that available even if you're reading the article. So even though this isn't part of the policy structure, code sharing is on everybody's list for what comes next. It was referenced by the OSTP as something that they'd like to see happen over time. And so the code that is also underlying the research, frequently tied to data sets, is something that we hope will be shared more and more frequently. And so we had DataSeer take a look at this as well. And you'll see that roughly 44% of the articles that have generated code have shared those in an online repository. Almost all of it is in GitHub, but there are other repositories as well. So this is interesting because it's the beginning of tying together these policies with open source. And it's an opportunity, of course, to understand how this code is being shared and how it can be made most usable. UCSC faces a number of challenges I'll be working with them on. You'll notice that that percentage sharing code, that probably represents those people who are already very well familiar with open scholarship and have been doing open source and open access and open data for many years. Usually there's a concentration within a campus of those who are already early adopters doing interesting work. The rest of the campus is going to need a lot of help with data curation, best practices, ensuring adequate metadata. They're going to need to know how to find the right repositories. They need to know what a PID is, a persistent identifier, and how to make sure that their data sets get a persistent identifier that's appropriate. We also need to think carefully, as we're going to see this sort of tidal wave of data sharing. We're going to need to think about what's the difference between throwing a data set up on a repository and true interoperability of data sets. So I'm beginning to fear, and it wakes me up in the middle of the night, that we'll end up with large data graveyards where repositories are filled with data sets that have been shared with barely adequate metadata in formats that aren't really interoperable and in ways that don't really allow us to merge those data sets into larger data lakes and even create the tools and everything that data hubs offer that make those large merged data lakes usable for many, many future analyses and meta-analyses. So if we think of that as a goal that we're hoping that the promise of open scholarship can bring us, we need to, backtrack to the point of sharing those data sets to try to help people share them in ways that can help us achieve that goal. So those are efforts that we'll be doing as part of this project within UCSC, and I encourage you to think about that with your own data sharing as well. We're also going to be trying to track unshared and lost data sets, trying to understand how to tie the code to the data for more containerized reuse. So frequently data sets, actually there is some form of code that was used for collection, for analysis, and often the data may be shared without that, which makes it far less than usable. So thinking about how we can couple these more effectively and create opportunities for people to be able to ingest and use a wide range of different research outputs. So I'm going to talk quickly about a case study in changing the way we measure impact. So one of the exciting aspects of sharing all these things is it gives us an opportunity to move beyond some of the traditional ways in which researchers and scholars get credit. So most of you are stuck in the same paradigm that we've all been in, which is credit is usually given through authorship of an article and the impact factor of that article, the number of citation of the journal that it's in, and the number of citations the article get tend to be sort of ham-fisted measures of quality that don't really apply to the work itself. But they've created this entire ecosystem where all of these metrics are used kind of ad nauseum and have in some ways sort of thwarted the entire research endeavor towards that end goal of a paper in a good journal. So if we take a step back and say, what if we're sharing all of these other outputs earlier on in the process? What if we have this much broader and more dynamic, exciting, real-time sharing of research? How does that change the way in which we assign credit? And so it's something I've been really interested in and worked with a funder that I've been working with for the last few years, Aligning Science Across Parkinson's, or ASAP. And we're looking to test how the reassignment of credit in more granular and useful ways can change this. So some of the things that we could be assigning credit for are how open are your outputs and at what point did you share them? What kinds of things happen to those outputs when they're out there in the wild? Are they being used? Are they being viewed, downloaded? Are they being built upon? Who else contributed to the work who may or may not make it onto the actual end article? Has it had any influence on people's decisions? Has it been reused in other people's work? Has it created opportunities for collaboration? So ASAP launched as a funding initiative, brand new funding initiative, about 4 years ago. And I had the ability to work with them early on to create this policy structure. And it's probably about as open science forward as they get. We require a mandatory preprint at the time of journal submission. All articles need to be made fully open access. We require the sharing of all research outputs, data, code, protocols, as well as resources like antibodies or plasmids or cell lines. Everything has to be put in the appropriate repository with a permanent identifier at the time or before that preprint comes out. It needs to be attributed to ASAP. And then we've created something that's sort of like a living data management plan, a research output management system that tracks all of these outputs from the moment that they are shared or even earlier, and they're shared within an ASAP hub, which is available just to the grantees, and then when they're shared publicly. And then we're beginning to track what happens to them out there after they're shared. So we're now several years in, and many, many different outputs have been shared by this cohort of 35 funded teams. And the hub has about maybe 1,300 researchers actively using it. And since it's a few years in, they've now published just under 200 articles, and you can see they've shared lots and lots of different outputs. The bioinformatics tools is the way that they call what they call software. And so there are 30 of those as of July. And this is exciting because not just are these now available to the world and out there, but they're tied to each other. So through the magic of persistent identifiers, you'll know if you're looking at a preprint or an article, which of these things worked together to make that work happen. So this is an example of a shared output. we set up a Zenodo community, which is a handy place to share things, by just one of many great repositories. This is actually a piece of code that was shared. So you can see that while the code is housed in GitHub, where it belongs, a record of it exists on Zenodo. And there are a couple things I want to point out. I'll get to authorship in a second. First is, by putting it on Zenodo, all of these people who have contributed to this code, all of their ORCID IDs are tied to it. If you've put something just on GitHub, frequently it's not tied to any ORCID ID or even necessarily a person's affiliation. So it's really hard to disambiguate who actually created this and who's contributed to it. And that makes it a lot harder to give credit. So this, by putting it here and taking that extra step, there's a sort of a record of it that's discoverable, that's indexed by lots and lots of different third-party services like Google. Also, you can start to see how many views and downloads this record got, and that helps us to start to understand the broader impact of all of the components of research, not just an article. So this helps to build up alternative metrics that can help us understand and assign credit and kind of and understand impact at this more granular level. Also, you'll notice here that David is the first author on this particular record related to the code. But when the article comes out, David is a middle author, which is probably appropriate for the article. But this way, as the funder, ASAP knows what David really did. And ASAP can now track that. So when David, who is an early career researcher in this team, not a PI, when David moves forward in time and perhaps applies for a grant later with ASAP, ASAP will know and credit the contributions that he made across all of the outputs. So whether it's a protocol, a piece of code, a data set, or somebody who characterized the antibodies that went into this, those people have the ability now to have their names, their real identities tied to the full range of different things that they've produced. So it's exciting on many levels, but I think you can understand how this could change the way that we think about impact in science. So there's this sort of, it's interesting to think about this policy structure, and the focus again is almost exclusively on the article. Let's make the underlying data of the article available at the time it's published. Well, that's not really that exciting if you understand the article is just sort of a description of work that's been done maybe even a couple of years ago in a flat file PDF with maybe some links. Here we are, 2023. So what's super exciting, and in the place where I think open source is going to have the greatest impact, is what's underlying that. What if we actually meant sharing the real work rather than this article in a PDF format? So people are doing super exciting things, and I'm excited through work that I'm doing with the Howard Hughes Medical Institute to be able to collaborate with research teams who are experimenting with one of the many new open data formats that are out there. This just happens to be the one I'm most familiar with, Neurodata Without Borders. So what this is essentially it's a container, and it containerizes data coming from many, many, many different sources. So imagine that this is a mouse, and it's a mouse experiment. And the mouse is in a big, huge maze, and the mouse has electrodes tied to its brain, connected to the brain. It's got all kinds of other electrophysiological and physiological sensors on, and it's moving around. So the data that's being collected by the investigator includes electrophysiological, neural, it includes behavior, it includes the mouse move from one place to another. So there's geolocation information. The mouse twitched or didn't twitch. The mouse responded, didn't respond. So there's just a wide range of different kinds of information. And what the Neurodata Without Borders does is it pulls it all together. So you can actually, when you see this in real time, which I've seen, it feels like you're inside the experiment. As a viewer, as someone who wasn't there, as someone who actually isn't even a neurophysiologist, I felt like I was inside this experiment, and at any moment I could move around in time and space and understand what happened at every second. And this is a container that not only is something that was recorded and understood and that I can then put in a repository and somebody else can visit, but it actually comes with a full range of tools that are all open source around it. So it's not just an open data format, it's an open toolkit. that allows for a full workflow around this. So what this does is it means that no longer would I, as a researcher in neurophysiology, be constricted by my own proprietary tool chain. I can now understand and comprehend the work of somebody from somewhere else who doesn't necessarily have, hasn't necessarily automatically used the same tool chain. So I can hand you a link and it says, here's my work. And without necessarily ever having the same tools, you can open that work up and you yourself can be inside that neurophysiology experiment too. So it's actually a phenomenal way of not just capturing the work, but communicating the work and allowing people who are not set up to do the same thing collaborate around the work. So without having the same tool chain, I could comment on your Neurodata Without Borders work, go in, investigate, download pieces of it, and understand it. So this is the true promise over time, right? This is where we blow the lid off of research communication and turn it from a paper-based sort of print legacy universe where papers are counted to real-time collaboration that crosses the boundaries of individual labs' constraints, that crosses the boundaries of software incompatibilities, and crosses the boundaries of what have been sort of cultural restraints on sharing. So that's where I see us moving in the future. And this sort of a thing is only possible through open source and open formats. Okay, so that was exciting, I hope. But let's just say, what happens when we don't invest in open infrastructure? What happens when we, in fact, allow proprietary and commercial interests to be central in research and research communication? So we've learned, I've been in the publishing industry for a long time, and we certainly learned from the commercialization of content with so much information locked behind paywalls that this is something that is a huge business and it's not going to go away quickly. Now we're looking at all of these other outputs being shared, data and things like that. And there is an opportunity for many to think about the commercialization of that. And those thought processes are already very well underway. There are a lot of proprietary platforms, and sometimes there are good reasons for proprietary platforms and softwares. But the paywalls out there that are beginning to emerge around things like even preprints, let alone data, are there, and they're strong. And we need to think about, what does that mean? The open source alternatives, setting aside this Neurodata Without Borders, which is a true phenomenon, often the open source alternatives are fractured and under-resourced. So before Neurodata Without Borders, everyone was building their own software toolkits and none of them talked to each other. And there were 3 or 4 different potential kind of data formats emerging that were competing, and people weren't able to share even the open source tools easily that they were building because there was enough fracturing happening. And that's not often resourced. That kind of creating the synthesis and cohesion is not necessarily something that's resourced because it's such a broad cross institutional cross-disciplinary type of effort. So while we're going to have this tidal wave of sharing, now's the time to really think about how to create that connective tissue that will bring it together more effectively. So let's turn back for a second to that study that we commissioned from DataSeer. One thing that we also learned is where things are being shared. And you'll see 32% on GitHub, which is exciting. But of the list here of the top repositories where people are sharing their data and code, there are only a couple of them that are actually open source platforms themselves. So Zenodo, OSF, and Dryad, those are all actually open source technologies. The repository technologies themselves are open source. Well, you might say, well, who cares, right? NCBI, that's not going anywhere. Elsevier is not going to be able to buy NCBI. And that is true. But those databases do not use all the same open standards. They don't offer, for example, DOIs for data sets. So you see some fracturing there. And others that are proprietary and are commercially owned could easily change hands, even GitHub. So what does that really, what kind of a risk is that for us? Well, I think many of you may be familiar with SPARC, the Open Access Advocacy Organization, and they published a report that they've updated. This happens to be the 2021 update, and it identifies a few concerns. One, for when infrastructure is closed. One is tracking software, which of course is huge, like for example, in course software, things like that, Blackboard, what have you. The collection and sale of data. Now, this is the big one, I think, that many of us are concerned about, which is when the processes by which research and scholarship and education are conducted are all done on closed systems, the how that happens, the who does it, all become the data of that environment. And that data is not necessarily owned by the people who are doing it or the institution that's providing it. So if you sign up for a course at UC Santa Cruz, who knows that? Who has that information? Who has access to that? If you are preparing a manuscript using a manuscript submission system, and that's going through peer review, who has access to the data about that upcoming work? And so this is an interesting and concerning area, because what we've seen is some of the large academic publishers and some of the other big providers in this space are actually buying up the technology platforms across campuses that house a lot of the content, people, and workflow from the scholarly process. So by doing that, they'll know what people are working on before it's made available, what students are studying, some of the trends in research in terms of what's happening even before publication, the products, services, equipment, things like that that are in development or already being used. And then the reach and influence, the collaborations, who's talking to whom, who's being, followed or discussed by various different governments. There's just an enormous amount of information that's out there. And then, of course, as AI will increasingly be conducting research rather than people, that's even more concerning, because we're just trying to achieve reproducibility with all of these different policies, and we'd go straight back into something that's even less reproducible, which is black box research being done. So it's important time to think about all the ways in which open source can intersect with scholarship. It helps us obviously make meaning of data. All of the code that fuels research is sometimes shared and sometimes not. And I applaud the OSPO in the work that it does, and I hope that we will have a UC-wide OSPO and that OSPOs become an integral part of every campus, because understanding the power of all of the code that is being created as part of the research process and how that code needs to be shepherded is really critical. It's also a possible way of redistributing credit for all of the aspects of research, not just the final publication. It has the potential for creating these amazing executable research packages for collaboration, and making sure that those are openly available to ensure a certain amount of equity as well in the access of these much more complex and rich data objects that are being created. Ensuring transparency and reproducibility, and then of course, securing data and personal information. Open systems give us the ability to understand exactly how information is being stored and shared and who has access to what. So I'll leave it there and open up the floor for any questions. Thank you.
The people in the room, you raise your hand, and if you talk loud, everybody online can also hear you. But so any questions? Thanks.
I have a question.
Oh, let's ask a question.
So thank you, Kristen. That was a fantastic talk. Really enjoyed it. So I was wondering, open science revolutionizing collaboration. I certainly look forward to that, and but I'm also afraid that it will cause some of the bottlenecks, as you can see now in the open source communities, where maintainers are overworked over things, right? And so I can see collaborators who share popular artifacts kind of getting into that same situation. Do you foresee any kind of gaps in the organizations of universities, in the institution of universities, where that could be alleviated? Yes, that's my question.
I mean, I would say, Carlos, this is a question for you, not me. I mean, I see what I see is a terribly fractured landscape. And where you see something like Neurodata Without Borders working, it's because of an enormous investment made by the Simons Foundation, the Allen Institute, and Lawrence Livermore Labs. I mean, they've done an amazing job putting this together, but it did not happen organically. It did not happen overnight. And in fact, getting adoption is going to take quite some time because it takes some cost and effort for a lab to adopt this new way of working. So it's as if we have this promise dangled in front of us, but the way to get there is incredibly complicated. And I think that an OSPO is a first step. An OSPO like yours that is actually actively looking for ways that it can nurture these kinds of community-driven solutions is also really, really critical. I also think it's up to funders to consider how to fund ecosystem-wide and fund what I call solution spaces rather than individual projects. So there's a lot of fractured funding. And the people who fund infrastructure are few and far between. Thank you to the Sloan Foundation for what they do. But it's not always easy to get that sort of funding. NSF is certainly stepping up a lot, which is very exciting. Their POSE grants and things like that are really encouraging. But what I would suggest is we need to think about solution spaces where we connect up people who are components of a solution, even if they may feel slightly competitive with one another. Because what we need are solution spaces that actively promote a longer term goal and solution. Neurodata Without Borders would be one that we could hold up and say, wow, that came from many, many stakeholders coming together, imagining and envisioning that future and then working towards it. But those ingredients are not, they're not magic, they don't just happen. So I think if we start to say, this is a problem space that we want to define, data set interoperability detection, for example, those kinds of problem spaces to avoid data graveyards, format exchange for large data sets, shared toolkits and environments that turn a data lake into a data hub where people can actively engage with it. How to offer, like NASA, for example, has great tools to offer free compute time to people for small amounts of compute that they may need. So these are the kinds of hubs that we need to be investing in. And they cross a lot of different boundaries. But as at the moment, again, we're at this very fractured stage.
A question, I mean, it seems that you built an admirable infrastructure for sharing research. If I want to become a tenured professor at UC Santa Cruz, the currency with which I'll be evaluated is my output of papers and the journals in which they're published. So it seems that so my question is there any effort to get universities to value publication in open journals as opposed to paywall journals? If I have a remarkable work I want to publish and I can choose to publish it in Nature or PLOS One, ultimately we need the employers to value the fact that you chose to make it open, and that will drive the behavior of the entire research world, it seems to me. So I wonder if any focus is being placed there.
You've hit the crux of the situation. The incentive structure still very much points towards publication in high impact journals. Of course, most high impact journals offer an open access option. So, if you're going to be compliant with UC policy, you would choose that option. And then there are even ways to pay for those APCs. But beyond that, the incentive structures are still very largely tied to those publications. And in many cases, those publications can be closed and there are no consequences to that. This new policy structure coming from the US federal agencies will demand that all of those papers be made open access. So that's a starting point, and that the underlying data be shared. So with that kind of policy hammer, you'll start to see compliance measured. So what does that mean? Does that mean that NIH or NSF is going to reward people who are open, who are proactively sharing data and not waiting to be caught with being uncompliant? Are they going to count that as part of the grant submission process? It's hard to know, but there are some glimmers of hope in this area. So for example, Howard Hughes Medical Institute, one of the funders / institutions that I work with, because they're sort of a bit of both, are no longer even allowing investigators to put the name of the journal on their presentations when they present at conferences. So if they have an article that they're presenting about, they have to just put a DOI or a PMID, a link essentially, and not the name. So that if it's a Nature paper, they cannot put Nature there. So they're already saying we're devaluing the name of the journal. It's not as important as the work itself. And you're no longer allowed to have bragging rights about what journal you've published in. And they also cannot use the journal name when they apply to be an HHMI investigator. So they've just announced this policy. It's brand new. It's an interesting experiment and we'll see what happens, but that's a step in that direction. There's another group called Helios, a higher education, something open science. I'm not sure exactly what it stands for, but it's a group of, I think, probably close to 100 institutions across North America. Presidents, provosts, heads of libraries are all represented in this group. And they're actively discussing how institutions can promote open scholarship. And the number one thing that they have lit on as the top thing that for them to focus on is tenure and promotion policies and guidelines to help to try to move the needle towards more open scholarship and less the final paper being in a high impact journal. So these are tiny little slivers. They're not what you need today or tomorrow. They're not going to change how your postdoc gets a job next year. They're not going to change your application process for most funding today, but they are starting points and I'm encouraged by them. And I'm literally week upon week seeing more of those popping up. And I do see a lot of conversations happening at the levels of funders around incentive structures and shifting those incentive structures. The funder that I mentioned that I'm working with, the Parkinson's funder, will be counting all of these different other activities and being able to assign and award credit accordingly. So we are seeing the beginning of it, and it starts with a commitment to the kinds of practices and infrastructures that even allow us to do that. If you haven't shared the data, nobody's going to be able to count or that you've shared it or cite that data set. And data citations can't then start to become something that is a form of credit. So we have to start at the beginning where the processes are more open, the sharing is encouraged and happening, and we're able to start to build new metric systems beyond just the number of citations that a paper got, or the impact factor, which is even worse because that's at the journal level.
Thanks, Kristen. This was a great talk. I have a question. You talked about, some caution about relying on non-open infrastructure. Mm-hmm. And I'm wondering what you think about that, or what we should do as a community about that. So when we think about like the sciences, like the science and research community, we rely on a lot of tools that are not open, as you mentioned, like GitHub, commercial cloud, things like that. But even more broadly as a society, in COVID, we kind of were able to work more remotely and still have collaborative interactions through, Zoom and Google Docs, Google Slides, and we all rely on using Zoom now. And none of these are open source, but they are free, or at least free to an extent. So I guess I'm wondering, do you think that we as a community need to invest our time and energy into finding other solutions that are, that are more open? And how does that interact with, being free versus open source?
So, I mean, it's a great question. I once met Richard Stallman. Many of you probably know who Richard Stallman is, sort of the grandfather of free and open source software back in the day. He refused to use anything closed source, which always meant that if you had lunch with him, you had to pay because the credit card system was, using closed source. And I'm no Richard Stallman. So we all are going to use what we need to use to get through our lives. And there's no way it can all be open source. And there's a role for commercialization, and there's a role for these things to make our society function the way it is set up to function right now. I'm more of a proponent of thinking, where is the most precious and vulnerable information? And where are the people who are tied to it the most potentially at risk, or if not at risk, where are there opportunities for barriers to advancement? So if somebody is locked away, so we've learned from publishers who basically locked away a lot of the world's most important information behind paywalls when all of the journals went online. And this made sense to them because they had subscriptions in print. Why would you not have subscriptions online? And they needed to make a profit. But we had an opportunity to vastly open up the world's information to everybody and kind of revolutionize our digital lives overnight with the advent of the internet. And a lot of that promise wasn't realized in the way it could have been. So I think the question really for us is where do we place our limited resources and time and demand that things be done in a way that align with values? And given that the resources available to the open source community writ large and even the open scholarship community are very limited, I would suggest we start with things like research software, the underlying software behind research that's communicated in a paper or elsewhere, reproducibility efforts, things like that. I also think that there is a difference between commercial and nonprofit, for example. So something might be open source but it's produced by a commercial company. That might be just fine as long as they have put in place various different ways in which that code can remain open. Something may be closed source and run by a nonprofit. So there may be trust in the governance structure of that code, even though it's not open. That may be perfectly acceptable too. So you have to kind of unpack governance from openness and from trust and from risk and look at that. So it's sort of a complicated answer page, and I apologize that it's not a simple one, but I think we have to start with what I consider to be the world's most valuable information, and that is scholarly information, and try to ensure that that is handled through, and in many ways as possible, the most transparent and open mechanisms and workflows. I also think we should invest in these big wins like Neurodata Without Borders, because those are going to give us the advances and they're going to set the tone for the rest. So those shining examples, I think we need to really publicize and make very clear to people.
That's our time, unless somebody have a quick. Oh, I'll give one minute.
Thank you so much for the talk. It was fantastic. I did want to talk a little bit about, or ask a little bit about neurodata and onboarding, if that's okay. Specifically around, because it seems like it's an engagement with the subject matter expertise community that sometimes I feel like onboarding someone into a repository with a sufficient level of complexity or something like that is really, really difficult. Even just for users, not even to mention contributors. So I'm just kind of curious about what are their successful wins they've had in that space, or like what are the things they do that really makes it a winner?
Well, I am not an expert in it, and I'm only beginning my exploration into what it takes to do this. It is not easy, right? So it's not something that any lab can immediately adopt. But what I do find exciting, where the sort of democratization aspect comes in, is if you were a lab that had already invested in this and you were trying to communicate with a lab that hasn't, they can still see it all. They can't necessarily delve into the data with the same degree and reproduce all the analyses, but they can see all of it. They can enter in and be that inside the experiment with just a link. So that's, to me, that is the promise, is that may then make that other lab excited to invest in creating their own Neurodata Without Borders processes and workflows and tools, or not. But they can actually go in and they can be inside the experiment and they can play with the data and they can understand it. So it's that containerization and that deployment in the cloud that makes it so powerful, so that it can fuel collaboration without that upfront onboarding effort for everybody involved. And this is important because many people will never want to do that because it's outside their field, but they need to be able to get in to see this one piece or that one piece. And so for them, that's where it kind of blows open the entire process for others to be able to engage with and learn from.
Thanks, everybody. I think